We'll get started. My name is Mike James, and just want to say thank you for coming. This is Mr. Stephen Boros, Pipeline Plastics, and today we're going to talk about big pipe, which we've been talking about quite a bit lately. So hopefully you learn a few things out of this today, and we got good Darren's in the room. We're going to use you in a little bit, so this will be good. So we want to educate everybody here. And first of all, we've got some great industry people in here as I'm looking around, people that I've worked with before, and a lot of good people. And while we may compete outside of this room, today we are united, and our goal today is to make sure that we as an industry are kicking everybody else's ass, not ours, right? Let's go after steel pipe and ductile and fiberglass and concrete. There's a couple seats up here if anybody needs. Guys, if you can, just check in too. For the new people, just check in and use this as your code if you don't mind. So I'm a big fan of saying that you create your own luck. And if some of us veterans in the room look back, you look at, man, how did I get that order? Or how did I get that customer? Or how did we win this project? If you really look back at how you got it, you created that. You created it because you were there, first of all. You showed up. And I think what I want to do is say thank you for showing up. Hopefully you'll get a few nuggets out of this today. I want to thank this guy for showing up. I'm lucky to have him. Good veteran here. Showed up.
So a few times. Appreciate it.
We have. So anyway, thank you again for being here. So we're going to talk about big pipe, and the topic of today's session is, how do we grow this large diameter market? We've had discussions all day long about growing our business, and I would say that probably everybody in this room has sold some big pipe. I would ask, has anybody sold 65-inch pipe in this room? Probably, right? 48-inch pipe, for sure. 36-inch pipe. Ron, you remember when we bought the first 36-inch fusion machine 25 years ago? That was a big deal, right? It's nothing now, right? I mean, it's crazy. Pipes are getting bigger. So has anybody sold anything bigger than 65-inch or fused?
Millimeters.
Or in millimeters, right?
1600 or bigger.
1600 or bigger. 1800. Darren? 1800, okay. So we've got a global audience in here, which is good. Mujib, where are you at? You're here. You're working on a 2-meter project in Abu Dhabi or Dubai right now, right? And so we want to, as I've been lucky enough to travel the world, some of us have in here, you see some of these things going on in other parts of the world that maybe we're not doing yet. And my goal today is to make sure we transfer that knowledge to this team, and let's go win some business that maybe we're not getting today. So, our pipe's becoming more popular for sure. So we're one team, we're one army, as Chip said today, of experts. We got a lot of experts in this room. And we've been blessed, all of us have been blessed with some pretty good business the last 4 or 5 years. We're all really good right now. When times are tough and we have to go win some business, hopefully you'll get a few nuggets today on what you have to do to go get that business, because there's a lot of competition out there. So growth in the large market. There's 3 takeaways I want you to have today. We need both hunters and farmers to chase these markets. Is Juan in the room? Juan Quintero, is he in the room? So I asked, he spoke yesterday and gave a great presentation on a job in Costa Rica. I asked him today, I go, Juan, are you a hunter or a farmer? He goes, I'm both. Depends on what I need to do, right? And we probably have a lot of management in the room. We have a lot of salespeople, right? I'm a management guy, but I'm a hunter. I'm a sales guy. I love to sell. I love winning orders. I also love to coach people. And not everybody's a hunter. There's some farmers and hunters, and maybe you have to be both. But we need both people, and I'll talk about that a little bit more on promoting the market. The market is going to grow. I think we've heard that message today. There's a lot of pipe going in the ground. We're infrastructure superheroes in this room, whether you think you are or not. And it's underground, so it's not always visible, but we're saving the world. We're doing a lot of good things. There's a lot of pipe in the ground, and it's going to continue to grow as our infrastructure ages and gets older, like Stephen and I. Right? And I think education and promotion is really, really critical. And we're going to talk about that. So these are the 3 takeaways I want you to remember, and we'll walk through this today and talk about it. So I'm going to give you a few slides on how big the market is, and some of this is not it's not global. This is more domestic, like what's going on in the U.S. The U.S. market, they say, is $127 billion, right? That's a big number. It's got continuous growth on it. The big thing is metal pipes own a big chunk of that market, right? They're the big player in this market, for sure. And they're going to have a lot of growth, and they expect them to grow to 150 billion by themselves, right? So there's a big pie out there for us to have. And we're talking about, increasing, Peter, you were talking about this, infrastructure investment. Mike Leathers talked about it. Our infrastructure needs it, right? Our dollars have to go to fixing our infrastructure. So there's a lot of investment in the market right now in infrastructure. HDPE, as you read all this, is emerging as one of the preferred choices in these markets. We're making a difference. And we know the benefits of our pipe. We know, I'm not going to beat that up too much, but we are becoming the preferred choice, one of the preferred choices in this. And we have great technology and advancements, and Stephen's going to talk about that in a few minutes on what is advancing in our market, the resins and the diameters, the performance, and so forth. The rise in conservation initiatives. I live in Arizona, Tucson, Arizona. Ron knows, you live there. Where's our water come from? Colorado. It comes from a long ways away, right? We're talking about leakage rates. We can't have any leaks. We need every drop we can get, especially where I live. In the West, we need it for sure. So the rise in conservation is huge right now. We all know that. And HDPE is a great solution for that. We're also talking about eco-friendly, and I just saw something about an hour ago on an email. We did a job at UC Davis, one of the biggest colleges in California, a chilled water job, and this is fantastic. I love it. The fence around the project is talking about how their campus is becoming green because they're getting away from fossil fuels, right? Ooh, that's a bad word now. They're doing hot water instead of steam, which means they don't have to use gas to heat their water. They can use electricity. Meanwhile, here's this fence with this banner, so 60,000 students get to read this banner, and they go, yay! They're brainwashing them, of course. On the other side of the fence, guess what's on the other side of the fence? HDPE pipe. What's it made from? Fossil fuels. We're trying to get rid of it, but here it is, saving the day, right? 0 leaks. It's polarizing, really, actually. It's kind of interesting, but eco-friendly. Environmental, we're hearing a lot of that for sure. That's important. So, a little more research. The demand for non-metallic pipe, especially HDPE and PVC both, right, is increasing amongst utilities. Huge cost savings and some of that, but the demand for it is there. More continued growth in the markets as well. I want to talk about, and Mujib, you might be able to help out with some of this, but yes. I want to talk about some of the other materials in the big sizes that we're competing against. We're used to dealing with maybe some smaller diameters where it's PVC or ductile iron or cast iron. When you get to the big stuff, it changes, right? It's GRP, it's Hobos, it's fiberglass pipe, and it's other materials that are doing some of these large transmission lines. That's our new competition if we're going to step up and get into these bigger diameters, right? And so I'm just going to share a little bit on Hobos. Who knows what Hobos is? Has anybody ever sold Hobos in the room? Put your hands down. Maybe somebody back there knows about it. This is our competition when it comes to large diameter water transmission lines. It's one of them anyways. So it's a fiber reinforced polymer pipe. It's got sand in it. It's got resin in it. It's a good pipe, right? And there's good pipes for lots of applications. It can handle some pretty high pressures, higher than what we can today. But that's changing as we come up with better resins, right? They say 150-year design life, 450 PSI. We can't quite do that today. So some stock applications, they use a lot of Hobos because it can handle those pressures. Great. But you don't always need that, and we've got some examples where we've been able to do some penstock lines that maybe aren't 450 PSI, and they just didn't know about it.
Right.
But Hobos is a pipe. As you get into the larger diameters, become familiar with some of this stuff and learn about it and educate yourself, because that's your competition. It's not PVC, it's now Hobos. Mike Leathers is in the room. He's got a little experience with this, but this is Northwest Pipe, right? And Northwest Pipe makes steel pipe in these big diameters. Same thing as Hobos pipe, up to 144 inch. 10 years ago, we weren't thinking about that, but today we are. Heck yeah. We're talking about some of these diameters. Now they can go up to some pretty high pressure ratings, right? But as Peter said earlier in the previous presentation, you got to line these pipes, you got to coat these pipes, you got to tape them, you got to weld them. That all takes a lot of time and becomes really, really expensive. But that's the options they're used to right now, the engineers and the owners.
It's a no, yeah.
It's a known material. Concrete pipe, right? Same thing, up to some really large diameters and some really heavy wall pipe, varying lengths. None of them as long as what we do today. But check this out for concrete pipe. We're talking about reinforced concrete pipe, vertically cast. It's interesting how it's done. Here's a project on 6,000 feet of 120 inch pipe, 15-foot length of pipe, weighs 75,000 pounds. 15-foot section. I did the math, and if we were to do that in HDPE, it was like that piece of pipe in a 45-foot pipe would have been 238,000 pounds. One piece of pipe compared to HDPE, 38,000 pounds. Think there's some differences on cost in the field and handling that? Big time, right? That's who we're competing against on the large diameter. Here's some more examples, and I wanted to give you just some real examples. These are off their website, so these are projects that they're doing right now, some really large projects, right? So bar wrapped pipe, 54 and 60 inch bar wrap pipe. They talk about bar wrap going up to some pretty high pressures. So we may be limited in some cases, but maybe not all of them, right? Steel pipe up to 225 PSI. But look at this, they've got some concrete pipe here lined with polyethylene, right? They're taking concrete pipe and putting polyethylene inside of it. That's got to be expensive. And why are they doing that? Why don't you just use our pipe? Probably because they don't know, right? Real life examples of some large transmission lines. 124,000 feet of 90-inch pipe, right? Some steel, some cement mortar line, polyurethane coated. 73,000 feet of 54-inch. These are jobs that we couldn't maybe do 10 years ago or even 5 years ago. But today we can do some of these jobs, but we have to go out and educate and make sure that the engineers know what we have available. This is who we're competing against on these large projects. And I think I'm towards the end of this. We'll let Steven jump in, but I want to show you this because this is interesting. This is a good example of some of the connections for some of the cement pipe. You don't have to look at the detail too much, but they have to weld it first, right? Then you got to mortar fill it, and then you got to put this diaper. They call it a diaper. This is lovely. They're using diapers. Concrete pressure pipe comes with a 2-ply diaper. How cool is that?
Eat the foam.
You need pipe with a diaper. We don't need enough, right? And you're not going to have corrosion with our pipe. You're not going to have bad welds. This is what we're competing with. That joint is really expensive to do, right? And they're shorter lengths, and there's a lot more of those joints. We have a lot of advantages. We really do. But just get familiar with what we're competing with for sure. Now back to the hunters and the farmer mentality, and I think about this because when I'm actually I love to hunt. I'm a big game hunter. I love to hunt. I love winning big projects. I love hunting them down. But I also know that you have to do your farming every single day. And I'm going to ask a question in here. Who has done a lunch and learn in the last 90 days in this room? Good. So we have a handful. If you're not doing those, we need you to do those. Continue to do those. Plant those seeds, farm those seeds, cultivate your crops. They're going to pay dividends. Maybe not today. And if you're management in the room, please tell your people to go do that. And we have a lot of people you can engage with. The Alliance is here. Stephen Boros is here, the manufacturers are here.
All of your manufacturers, yeah. We're happy to come out there and help you do it. So feel free to reach out to us to help organize it, prepare it. You get the audience there, we'll be more than happy to come and do it.
I would guess some of you that have done this, right, and I do it as well. I mean, you've won some projects. It takes time sometimes for that to happen, right? And I'll give you a real life example of one that I did. I love to hunt, but I also know that the farming aspect of it is really, really important. So make sure you're doing both.
Because that's, I mean, Mike's right. On that point alone, I mean, a lot of us have seen that. It takes a long time for this to work its way through the system. Like I said, we have an engineering firm that says, hey, I need to learn more about polyethylene pipe. Not because he has a project today that he has to put in. He just sees the guy in the next city over is doing some of this. And he knows if he wants to keep designing systems, he's got to know about that too. So you come out, you do the lunch and learn, you develop that relationship, and then 6 months or next year, guess what? The guy's calling you up saying, hey, I got this project. I think polyethylene will work really well for me. What do you think? We go through the design, get him over that edge, give him the resources in place where he can go get the tools and information. Next thing you know, he loves it because it worked extremely well. Now he's doing all of his projects that he can in polyethylene. So it takes time. It does take time to plant that seed and to farm it.
The Alliance is doing a great job of that. I mean, you're touching a lot of people with what we're doing, and I think as an industry, even if you're not using the Alliance, we have a responsibility to do that. And one of the things that we should be talking about is life cycle analysis, life cycle costs. If you start doing that, and I'll show you a book here in a minute about that, I think this is very impactful. If we're comparing how much your pipe is per foot, and that's all they're looking at, and then they got to buy a fusion machine, and that's not a fair analysis. We have to do the full life cycle analysis. That same job in California I was talking about, I learned a valuable lesson. We were up against thin wall European steel that was going to be insulated and HDPE pipe. And when we started doing the comparisons on the two, one of the things I learned was on the steel pipe, they came back and said, oh yeah, we have to have a treatment plant. And I went, what do you mean a treatment plant? Yeah, if you put steel pipe in the ground, they actually have to sell you a treatment plant to operate that system for the life of the system. Treatment plant? What do you mean? Yeah, we got to continually treat that pipe so it doesn't corrode and do all that stuff. Well, hold on a second. You're comparing us price per foot to price per foot. How much is that treatment plant? Well, it's like $800,000 or $1 million bucks. Plus you got to operate it. I'm like, oh, time out. That's not fair. So we got to make sure that we're talking about that stuff because they don't always think about that. I'm going to let Stephen take over and talk about some other fun stuff.
Oh, great. All right, thanks, Mike. Appreciate you setting that stage. So what's allowed us to come to these bigger sizes? This is a slide you guys have probably seen 100 times. So it's a progression, right? We've come, don't press that button. I'm trying to find a pointer, but I can't find it.
I don't know if there is.
Anyway, all right, so we've seen the progression over time. So where we are today is this area over here. We've gone up to high performance, what we call high performance polyethylene materials. We have the term PE 4710s, but there's various families or groups of PE 4710s. So what's allowed us to come to these larger sizes is the technology of how we develop those. And it's really come with the molecular weight distribution and the way we've been able to manage that. So we've all heard the term, I'm going to get a little bit on my soapbox here. So we've all heard the term bimodal, right, over the years. Oh, bimodal brings us all these wonderful things. Bimodal's great, but we need bimodal. You see it in the specs. Bimodality, this is my take. Bimodality of the molecular weight distribution brings you relatively little. It brings you a little bit in processing, brings you a little here. But what it allows you to do is now to tailor that architecture in a certain way to get properties that you want. Not the fact that it's bimodal that gives you that. There's other ways to do it, but now you can manipulate this part of this high molecular weight end a little bit. Get your side chain branching that gives you your long-term strength, slow crack growth resistance, all the things we've been talking about and tried to optimize over the last 20 years. But now you can manipulate a little bit more to develop what we call the low sag materials, right? So you probably all heard those terms as well. So why is sag important? What's kept us from making large diameter heavy wall pipe in the past? Well, some of it's been our equipment and technology that we use on the processing side, and that's come a long way, but some of it is also the resin itself. So what happens is we like to have a pipe where the walls are pretty uniform all the way around. But if you have materials that sag as it's going through the process of forming and cooling and solidifying and making a wall, you start with a thick wall at the top, but you end up with a thick wall or a thin wall at the bottom. Excuse me. You start with a thick wall up here and it all sags down. You end up with a thick wall at the bottom. Well, that doesn't help. So you have to be able to control that, right? So you do it with tooling. So initially you start, well, say I'll just adjust my tooling. I'll start with a really thick piece of resin on the top. And it'll kind of all sag down. It becomes more of an art than a science of how I accomplish that, because the speed of the line, the amount of cooling that you do, it becomes much more of a challenge. Well, with what we call the low sag materials, you don't get that slumping of the materials as much anymore. So now you can make a much more uniform wall thickness of these larger sizes than you could before, and process them more quickly, because you're always limited by cooling. How fast can I cool that pipe, right? That's what's going to be key into how thick a wall I can make or how big a piece of pipe I can make. So if you become to optimize that, and that becomes less of an effect, that allows you to do more things that you couldn't do in the past. So that's kind of where we are today with this technology. So this is a general size chart. I don't know if you can see it or not, but so as we go to what we call large diameter, I just started here at 34 inch, went up to 65 inch, because that's kind of what's available domestically. I mean, you can get larger than that, of course, but just give you a general idea. So in the past, we would kind of limit our sizes. Here's the DRs as you go across. As you come across this way, of course, you get the thicker wall pipe. Lower DRs, thicker wall. You can see that we pretty much stop relatively around the 3-inch wall thickness area. So here's your minimum wall thickness, 65 inch, DR 21, 3-inch, all the way down here, 36 inch. We do some 36-inch 9 now and things like that, but that's typically where you see the size charts would stop, except for special occasions. Then we went to, well, where we are now, pretty much, is to this next level here. These green boxes are where we're going now. Where 4 inch is not too uncommon now. You see that on a lot of just common data sheets where you can go down 4-inch wall thicknesses. So that brings us a whole nother pressure class into performance that we didn't have before. So now you're getting into 54-inch DR13.5, which has a pressure class of 160 psi. That opens up a lot of windows now into these markets Mike was talking about that were traditionally steel, Hobos, concrete, that nobody even considered polyethylene for in the past. So that's why I think we're finally seeing that, and we're seeing more large diameter jobs going to polyethylene. Now the yellow is really the next step, and I think we're going there very quickly. That's going to be getting up in even to the 5-inch wall thicknesses. So it's thick pipe, but it can handle it, and you can now reach these pressure classes, which you couldn't do in the past. That opens up a whole nother range of possibilities for polyethylene. So you can see what's available today. So here's I think this is about a 65-inch or 63-inch line, I think, or piece of pipe. And you can see the relatively wall thicknesses that we're looking at. I mean, these are huge. Now, I don't know if that was used for feedstock to fittings or for pipe, but it could be either one. And it allows you to have, the fittings that need to go with it as well. You need the thicker wall material to make the fittings that goes in conjunction with it, because the pipe by itself doesn't really do you any good. So you can see the opportunities and the things that you have available to you. So you have all the fabrications that you can do, the elbows, the flanges, the tanks. I don't think I'm touching anything. All the things that this brings about and the fittings that go with it also. We're here to talk about fusion. We love fusion, but fusion is the way to go whenever possible, but it's not always possible. And a lot of engineers know that, and they want options for that. So one thing that was always, I would say not crippling us maybe isn't the right word, but holding back on some engineers making that decision to go with polyethylene was, well, how do I join it if I don't have a big fusion machine available? Well, now we have many different options for joining polyethylene mechanically. You got the repair clamps, which you can use on any OD size pipe, work on polyethylene just fine. But you have a lot of different options for couplings up to pretty much any size now that are made specifically to work with polyethylene. So that opens up, again, a whole nother avenue and takes away an obstacle that the engineering firms had to designing with polyethylene pipe with these in the past. I think this is more back to you, Mike.
I think back on the fitting side of it and the mechanical side of it as well. I mean, if we go back 10 or 15 years, you know, some of that stuff wasn't available to us in the market. So if we're going to do a large transmission line, we didn't have all of those fittings available. And whether they're a repair coupling or a mechanical coupling or fusion, we have all of that now. So if somebody puts a backhoe in a piece of pipe and you need to temporarily fix it, we've got those items to do it. Peter does a great job of showing that in his presentations. The PPI has those documents available as well. All of that's available. And if you don't know where to get it, reach out to any of us and we'll help you. I'm sure probably everybody in the room knows how to do that, but it's available. So part of this presentation, we want to talk about applications, challenges, and success stories. I'm going to roll through that. These are some of the markets that we're working in today in our industry, right? We're going to start out with water and wastewater, and I'll show you some examples of that. Before I get into a project case study, in the U.S., our infrastructure is getting very old and graded. We're at the U.S. water system's at a D and a D plus respectively. It's pretty old and it's in pretty bad shape, right? We've got wastewater treatment plants 50 years old, wastewater collection systems 80 plus years old, wastewater pump stations, interceptors, all this stuff is aging. It's great opportunities for us to go in there and educate everybody and help us, you know, we shouldn't be D's anymore, we should be better. The EPA, I found this document, I found this interesting. The EPA even puts out the advantages and disadvantages of all of these different materials. So it's really easy to see. Talks about ductile, concrete, clay pipe, which really isn't a big deal. Thermoplastics, meaning PVC and HDPE, we have a lot of advantages. And when you go to the disadvantages, most of these are PVC disadvantages. We really have a ton of advantages over ductile iron, right? That they say is good corrosion resistance when coated, right? High strength, yeah, high strength for sure, but heavy, right? Concrete pipe, good corrosion resistance when coated maybe. It's available for sure, high strength, but requires careful installation to avoid cracking. Heavy, I told you that earlier, and can be attacked by H2S for sure, and I'm going to show you an example of that. Anyway, this stuff's out there if you need it. And if you're going to go into an engineer, make sure you do your homework and make sure you bring some data to them. Mike talked about that earlier. Have a compelling story, right? Make sure you're leading them to it. You're not just beating your chest about HDPE. Peter, you showed this a little while ago in a previous presentation, but this is a great example of a PCCP pipe that was put in the ground a long time ago and is supposed to have a 70-year life. Right? As I researched this a little bit, these pipes are supposed to last for 70 years. That's pretty good until the steel gets corroded, right? So concrete, but it's got these thin bars of steel in there and they're not strong enough and they get corroded and this is what happens. And we're seeing this all over the country, right? This is happening.
I need to give you a little anecdote on that. So this is a huge problem around the country if you guys aren't familiar with it. And so at the ASCE, American Society of Civil Engineers Pipelines Conference, there's always a lot of papers and case studies on inspection of this type of pipe. So it's a whole industry now where municipalities hire these inspection companies to come out and they run a inspection tool or a current through their pipe to find out where the broken wires are. So they can do it from a continuity test that they do. And they've become really good at identifying if we have 5 broken wires per foot. I think that's, I don't know if that's the exact metric. We know that the potential for that pipe to fail soon is very high and you should consider replacing it. So they talked about I think it was WSSC in Washington, D.C. talked about how they spent $2 million a year. They budget every year, $2 million a year just to do these inspections. Not to do the replacement, just to do the inspection, tell them where they need to replace pipe. So they're so proud of themselves that they've been able to pinpoint where the failures are going to occur and replace those quickly. And then the next year they do it all again. The next year they do it all again. So the conclusion at the end of it by one of the reps from that industry says, so in essence, PCCP now has an indefinite service life. And I'm going, how do you get to that? Everybody's like, yeah, that's a great idea. And I'm thinking, that just doesn't make any sense, but that's kind of the mentality we're working with now, and that's the age of our infrastructure that Mike was talking about. And those are the things we got to get past, that type of idea of let's just find better ways to find the problems and fix them instead of, one foot at a time essentially, or one stick at a time versus wholesale replacement for 100 or 150 years coming up. So it's a big problem out there, but that's the mentality of what we're trying to work with. And as you try to find that hot button with the engineer or system owner, that might be one of the things that takes hold, is he needs to figure this out also.
I guarantee if you go in and talk to a municipal engineer, they know about this. I mean, they're seeing these problems. Compromised joints, right? And it leads to the thickness on the steel is susceptible to corrosion, right? I mean, these things are happening. It's happening in Tucson where I lived. It's happened a bunch. We've done a bunch of bypass jobs and so forth. So to fix that line, what do? They come in and use HDPE, right? We save the day. They come in there and slip line HDPE in the middle of it and fix it. Peter talked about it in his presentation. We use all of our advantages. We come in there and we slip line it. Right? There's no other pipes that can do that. This is really good for us. We need to educate, though. We got to continue to educate the engineers and the municipalities. Stephen did a great job talking about this at the last Pipelines Conference a couple weeks ago.
Yeah.
I'll let you talk about the Utah project.
Yeah, it was a good project. And you may have seen this before. So this is a project that we produced the pipe for. It's 63-inch DR26 pipe, about 33,000 feet, I think it was. So the idea, though, was to redirect a water treatment plant effluent line, or effluent pipe, from one section of the Great Salt Lake to another section because it was creating a mismatch in fresh and salt water because the Salt Lake was drying up. And it was creating all these environmental issues, algae blooms, all sorts of negative things, phosphites. There's some new state of Utah requirements on nutrient levels and different things that you can have in these sections. And so they had to redirect it. It was like, well, let's stop putting that water into the Great Salt Lake, which that wasn't an option because you can see here over the last, 30 years, from 1984 to 2016, you can see the Great Salt Lake is drying up quickly because there's no more water going into it as much as it needs to. So they didn't want to remove that, what I think is like 30 million gallons a day of water from going into that Great Salt Lake. So they developed this project to redirect it. Okay, so it's the Great Salt Lake, right? So how many different products, piping products, do you think they could install there that might work? Probably not too many. They settled on polyethylene really fast, and I was working with the engineering firm from HDR that was doing it, and he was really insightful on this. He had a lot of good information. He did his homework. He studied polyethylene. He knew how to design with it. We had a lot of great discussions leading up to actually installing the pipe. Before we even started delivering it on site, we had conference calls with Whitaker, the construction firm, HDR, ISCO, the distributor that managed that project, and we all got on the same page as how we were going to do it. And a lot of interesting questions came up. And the one kind of funny was we first sent some pipe out there, and they were looking at it. The engineering guy was out there looking at it, Mitch, and he goes, this pipe kind of curves in on the end a little bit. He goes, this is a gravity line, so we want to make sure it's totally flat. It was a very low slope line, and they want to make sure it was very flat. So, it toes in a little bit, and we don't like that. I said, well, that's part of the polyethylene pipe process, and there's an allowance for it. And, it's not going to cause any hydraulic issues. A lot of studies have shown that. And he was like, well, can you just cut that end off before you ship it out to us? And I'm like, well, it doesn't quite work that way. So you have to get into these little, discussions with them about, okay, well, here's what toe-in is. Here's why it's there. And every foot of pipe's going to have it, so we can't get rid of it. It's just that when you cut it, you fuse it quickly, it's going to mitigate that toe-in a little bit more, and you can work on it that way. So just lots of little things like that. How do you load the pipe? How do you unload the pipe? Not real easy. Anyway, just those things was a great project. And he talked about the corrosion aspect. So one of the slides in the presentation, I had some steel pipe and concrete pipe corroding, and the guy reviewing my paper for that conference was a steel pipe guy, and he goes, I don't think these pictures are appropriate. This isn't part of your paper. I'm like, well, it is. It's about corrosion. It just shows why you couldn't use it. And so the engineer, Mitch, was talking about when he presented his section of it, he said, it was so bad, we had to use stainless steel rebar in every piece of concrete block that we poured out there. And we had to use stainless steel wire to tie the rebar. He goes, the contractor had a roll of regular steel wire that he dropped on the ground one day. He came back the next day and it was totally corroded. It works that fast. So that goes to show you there's not many products that could have been used in this environment. I mean, long story short, they did a 6.25 mile project to redirect. They designed it for up to 60 million gallons a day of flow. So it's going to work very well into a different section of the Great Salt Lake, so they get the right amount of fresh and salt water in the right places. And it was a great, what we call an ESG success story. You know, it was a win-win-win for the state, for the people, for the environment. Also with polyethylene, we were able to ship 450 fewer trucks of pipe out there because we were able to get 90 feet of pipe on a truck, a 40 foot and a 50 foot, instead of traditional materials that would have been about 40 feet per truck. So we say 450 trucks going out there. If you go through just the CO2 savings from that alone, was about 180 metric tons of CO2 reduction just from that portion of it alone, not to count all the other parts that go with it. So there's a lot of ESG. We hear the term a lot, but we really don't utilize it in our everyday usage of how our products benefit that. But I just thought it was a great story to bring together about how engineers thinking outside the box, construction or contractors thinking outside the box on that, are able to do some great things with this large diameter pipe that they couldn't do before. Oh, this was a great picture too. So this is one of my favorite pictures. So one of the things is they were doing this along a causeway, and they had very narrow right of way. You can see here the Great Salt Lake where it's receding. He said by the time they started this project to where they finished it, it had already receded about another 300 feet. So they had to extend it even further before it went out. That's how quickly things change out there. But they were able to fuse the pipe up above ground, 63-inch pipe, and then lower it into the ditch as they went. So it was a huge savings in this narrow right-of-way they had to work with, while keeping the causeway open for tourist traffic and things like that to a very popular part of what they call Antelope Island. So, and then they make some headers and attachments, things like that, off-site to bring in. And I think that was it. So anyway, I thought that was just a great story to bring the whole environmental aspect of the benefits of polyethylene in it as well.
Deanne Hughes talked about the carbon footprint impact yesterday in a session we had, and I found it really interesting. There's a number for that, right? Every country has. I'm still learning about it, but ESG, carbon footprint. If you can save that and show those savings on a project, save that many trucks, there's a cost to that. And if you're not being asked about that yet, you will be, right? These people are going to start asking you to fill out these forms and start showcasing, because they need to show it to their owners as well.
Right.
It's huge. So I like these pictures because it shows really all of, and this is a core and main fusion machine, by the way. Anybody in the room, core and main guys? This is your equipment on our pipe, so we're working together, right? But it's showcasing really all of the McElroy tools in this case, which is helpful. Darren, you're in the room, if you don't mind. Darren's from Australia. He's owner of Gem in Victoria, right? Down south. Why don't you talk about this, if you don't mind? Stand up, explain. This is an 1,800 millimeter job that they use the talent on, and there's a great story behind it. Why was it used, Darren?
So this is Melbourne's effluent treatment plant that treats around about 50% of Melbourne's water, Melbourne's soil. You can see the ponds in the background on the photo on the right. It's very much a pond type system. There's a couple of bioreactors out there now. Actually, there's a lot more today, but the older part of the system was all pond related. There was a concrete pipe installed some years ago, around 7, so not that old. That was installed under one of the treated water ponds, but it was flowing untreated water. That pipeline broke, 7 years, was leaking around 40 megs a day. So we had to bypass that pipeline. It's not a very long pipeline, it was only about a little bit over a kilometre, so 600 mile, something like 0.8 of a mile. It was a gravity pipeline. Yeah, HDPE was chosen. Thin wall, very thin wall, 50 millimetres, 2-inch wall thickness.
Were they considering anything else besides
We
HDPE?
really didn't have an option because you can just about see it on the photo on the right. The ponds were very, very close together, so around about 30 feet between the ponds. So we had to make space for the pipeline. So we brought earth in and stabilised sand, built the earth or the space for the pipeline, then dug through there and laid the pipeline in that area, then backfilled with concrete. So there was no space.
Darren's a HDPE fusion champion down in Australia. If you don't follow him on social, you should. His company is fantastic. They do some really, really cool projects, and thanks for talking about that. Appreciate that. I'm going to speed up a bit. We're running short on time. So moving on from water and wastewater, if we're talking about irrigation and hydro and open canals, and these are all great opportunities for us as well, especially in the West where I live. We have a ton of these open canals, right? And it just doesn't make any sense. My water, it used to be Ron's water, it comes to Tucson, comes in a lot of open canals all the way down to Tucson. It's crazy, the seepage and water loss. That is a big deal these days, and we're starting to do more and more irrigation projects. Hydroelectric projects. This job here actually was an irrigation job up in Oregon, and I'm going to tell you a story how we planted some seeds and I was able to go hunting later. I planted seeds on an engineering call. It wasn't a lunch and learn, it was an engineering call visit outside of Seattle. Small engineering firm, you drive by it every day, you wouldn't even know they're there. But we got in there and met with this one guy, planted a seed, and I don't know, a year or two later he calls up and goes, "Hey, I remember you coming in. I've got some guys in Central America. Do you have a job in Texas or Florida or somewhere they could fly to? They have some interest in HDPE. I'm trying to convince them to use HDPE." I'm like, "Awesome." I go, "We do. We have lots of projects, but we've got a big one going on in Oregon right now. Can we get them up there?" Sure. The next week, we all fly up there together. First time meeting these guys. 3 guys from Guatemala. They had not seen HDPE like this before. They're touching it and feeling it. And this guy in the middle was a steel guy that'd been around forever, from Liechtenstein, put in steel pipe all over the world. He was not a fan in the beginning, right? But Rudolph, the tall guy in the back, was. And we showed him this project, took him out to dinner, had some fun. At dinner that night, he goes, "Can you be in Guatemala on Tuesday?" This is Friday night. I go, "Yeah, of course, sure, let's go." Went down there and we ended up walking that job, ended up selling that job. It took a few trips, sold that job, and consequently, I think it was the first big hydro project that they used HDPE. Where I think we're on our, is Carlos in the room? Shane? We're on our 3rd or 4th job down there, I think. And it all started because of one engineering call in Seattle that led us to this project, right? Plant those seeds, right? We got a farm every day. Some other quick examples, and this is Guatemala here. These are walking the job with them the next day, very hungover. We kept walking, and I go, "You don't need any elbows here. None here. Maybe a couple here. None here." Halfway through the job, we're sweating and tired and hungover. And Rudolph's like, "Mike, you're telling me we don't need all these elbows?" With steel pipe, they need an elbow with every change of direction. They're used to putting in those and then having to weld them and do all that, wrap and coat and do all that. I go, "You're going to need some elbows. You're not going to need that many because we can do that," right? He couldn't believe it until we did the job. So great example. This is in California, another irrigation job, and I show this one because, and this is probably a decade ago, we had the Mega Polyhorse out there. It's a great tool that McElroy has. And if you have some of these jobs, these large diameter jobs, make sure you have the right tools on the site. It's going to help your job go so much quicker. One guy loading pipe to himself, fusing it, and somebody else pulling it. 2 guys, that's it. If that was a steel job or a Hobos job or something else, it'd be way more people, right? So those are huge impacts for sure. So total cost of ownership is much better. These are some of the tools. You all see them here, but these are real life examples. That's up in Oregon. I forget where these other ones are, but these are great tools to have. This job in California, you probably have all seen this before, but this is the very first job we did with the Talon, right? And it was done in California, in Central California. And this job, was a steel pipeline that we were fixing, and it was a private almond farm using a lot of water, by the way. Anybody drink almond milk? I do. It uses a ton of water, right, to grow almonds. This Baker Farm project had a steel pipeline that was put in like 14 years before, and it was just springing leaks all over the place. They decided to fix it. One of our good customers said, I think we have a solution. We went out there and we did a 54-inch pipeline project using the Talon very first time, knocked it out, huge success. Irrigation, right? Lots of opportunities for that as well. This job is another irrigation job. We did this one in Idaho a couple years ago. That was a PVC job. And Peter, you talked about it earlier, but you know, when COVID hit, PVC prices went skyrocketing and they started looking for alternative options. That would have been a PVC job. And we got a phone call. How much is your pipe? Can we look at it? What are the advantages? Let's go meet, let's go talk to them. We actually went out to the actual owner of the project. And once we do that, once you get to the owner and you show them the benefits, they go, why would I want anything else? This is what I want. I don't care if it costs more, that's what I want. It was less money at that time, but that was a huge job we did. One of the first jobs with the I-Series, actually. I think it was one of our very first T900 I-Series jobs. And then I think y'all have seen this one. We probably have talked about this one a lot, but this hydro project, the Bradley hydro plant up in Alaska, this is a great ESG water savings project, taking natural glacier runoff water, just like I was doing in Guatemala, except it wasn't glaciers, capturing that water and sending it to the lake where they're using it for hydropower. And this increased their hydropower capabilities by, I forget, 20% or something like that. You guys were on it. It was pretty significant, right?
20% for sure. Yeah.
And I don't know if they were looking at other materials, but you know, before HDPE, they would have to. That probably would be a steel pipe job, probably, more than likely, right? And look at the advantages we have with HDPE and the Talon and the fusion equipment.
That was a big reason why GMC decided to go with that. Because
Yeah.
they could curve it around, they had to build those roads. I was on this project
For a while.
three months.
For a while.
I'm basically a leader. But yeah, that was a huge benefit because they literally blasted their way up the side of this mountain, took that rock from the mountain, ground it up, made the gravel, that made the road that we could then drive up and put the pipeline.
And I guess if you deal with any hydro projects, you know, a lot of hydro are a lot of pressure. There's a lot where we just can't handle it. But you should get in there and educate the engineers and go, listen, we can handle some of those. Maybe it's a combo line. Maybe you're using steel pipe at the bottom, but maybe the first section we could actually use HDPE. Or maybe you should rethink how you're doing it, and you can actually use HDPE for a lot of it. So just keep that in mind on the hydro side. This job we just completed not too long ago, Steinecker. This is the largest solid wall HDPE pipe in North America. We wouldn't have done this 10 years ago. 78-inch pipe. We didn't have the capabilities, right? This stuff can happen now, and it is happening, right? And the fittings and the fabrication and the capabilities, that is all very doable today. 10 years ago, it's not. I'm going to predict 10 years from now, 20 years from now, I mean, this is going to be commonplace. 78 inches is going to be like, oh, that's not so big. It's probably like 36 inches today. We'll be doing 120 inch, right? It's going to happen. So great markets for it. You want to add something?
No, I said they're already doing it in the Middle East.
Yeah. This project, the one I just showed, the Steinecker, had a lot of other benefits as well. Public safety, no open canals. Nothing's falling inside the canal. And we had a couple of guys in New Mexico on a siphon job recently, and John told me, he goes, I actually saw a dog floating down the canal. We're looking at the siphon, and here comes a dog, and then here comes his owner chasing him, and they're both in the canal. The dog got into the canal. The guy jumped in to try to save it. I'm like, you saw that right in front of you? He goes, yeah, we had to throw a rope in to save him and pull the dog out. Put it in a pipe. You don't have any of that. Right? Better save him. Yeah, exactly. Save a dog. There's a story. There's a compelling story. Anyway, there's a lot of benefits. A lot of benefits to it for sure. If we talk about outfalls, marine, and offshore projects, I'm going to quickly go through this because I think we're short on time. But we've done some really cool projects offshore, and I know Mujib, you guys do that in the Middle East a lot, right? I talk about that. There's a million desal plants in the Middle East, right? What are they using? They're using a variety of pipes. HDPE, GRP, right? Very, very common. So sinking pipe in a body of water should be a no-brainer. HDPE is the choice, right? However, when you get to large diameters, the one we did up in Canada, McLaughlin, was we didn't have capabilities of doing that until recently. That was going to be a steel project. Have to weld it up, take it out, float it, do the same thing, maintain it, all that. When they found out that HDPE was available, they quickly switched it to HDPE. So projects, Niels, you probably see this all the time, right? Where you're at, it's very, very common. So, and what I would tell you is, if you're not calling, if you're in a coastal environment, if you're not calling on marine engineers or marine contractors, go do it, because they need to know what we're capable of today. They may know what it was 10 or 15 years ago, but educate them today on what it is, and I'll guarantee you there's some opportunities out there. Let's go to trenchless. I think this is where we shine, right? Everybody probably has done a bunch of trenchless work, right? A lot of directional drilling, a lot of large diameter. They seem to use our pipe in all of the toughest applications. Let's use our pipe to directional drill and then transition to something else. Kind of crazy, but they do. But there's a lot of advantages for trenchless. This was the job in Fort Worth I took just a couple weeks ago. Look at the flexibility and capability of it, right? It's really good. But what I want to talk about is like maybe some other options where you can use trenchless in kind of a hybrid situation. And this job in Colorado, the Colesman Tunnel, was a clay tunnel, been around for probably 50 years, started to corrode, started to fall apart. They were trying to come up with a solution on how to line this tunnel, fix this tunnel. CIPP was considered, maybe excavating and doing something else. But when they pulled in one of our contractors, we were able to go sit at the table with the engineer and come up with a solution to put 48-inch pipe in there and using a directional drill to pull the pipe back through the tunnel, right? And so it was kind of a hybrid, wasn't a drill, but it was using the drill to pull the pipe back. Heavy wall, 48-inch pipe to provide a solution in a funky shaped tunnel. This job in Tucson, Peter was with me on long ago. Concrete pipe, same thing, abandoned concrete line in the city of Tucson, south side of Tucson. We need more water, so we're going out to get water wherever we can, and we needed to go out south of Tucson to get water from some new wells. They had this abandoned concrete line just sitting there doing nothing, was out of service. 36-inch line, we were able to slip line it with some 32-inch pipe, revive that whole pipeline. I think it was about 30-some thousand feet of pipe. Presto, you got a brand new pipeline. Great advantages. Peter talked about Tolt pipeline up in Seattle. This was a great example. Same story, right? Abandoned concrete line that hadn't been used. Had some seismic issues up in Seattle. Concerned about that. What's the answer for that? HDPE pipe. This was an important water source. It's 60% of Seattle's watershed, right? So it's important. 2 redundant lines, and they had this failed concrete line. Let's put HDPE in there. All right, one of the messages I want to say, if you're dealing in the trenchless industry, we all know the advantages of it. There's some other methods out there like spider plow. If you haven't seen that, that's pretty interesting. You know, the tight liner or the Murphy method, what do they call the Murphy? Swedge lining, thank you. Those are all great stories and great ways to use HDPE. What I want to challenge you with, though, is who in the room's called on the other manufacturers of trenchless equipment? Ditch Witch and Vermeer and those guys. Has anybody called on them before? Have you joined them at some of the industry events that are local? If you haven't, go call on them. You're not going to sell them anything, but you're selling the same customers. You're selling the same contractors that are going to put your pipe in the ground and are going to lead you to some projects. If you haven't been by Ditch Witch or Vermeer or some of these other TT technologies, get familiar with them. They're in your area. Go meet the local branch and the local sales team. Make friends with them. Tell them what you can do. Educate them on what our capabilities are. They don't know it. I didn't know HDPE went that big. You mean we can do those diameters? I guarantee you they'll stir up some leads for you. I would go do that. So let's talk about the outlook, Stephen. I think that was one of the things we wanted to end with. What's the outlook on HDPE pipe?
Well, as I said earlier, so the new materials we have out there, the low sag materials, I mean, they're out there, everybody's using them now pretty much, and they're getting better. And there was a great paper presented, I don't know if any of you were at the Plastics Pipes Conference a couple weeks ago in Orlando, probably the world's largest technical conference specifically on plastics piping. Anyway, there was a great paper given by one of the resin companies there, Lyndell, great rheologist there, that showed exactly why they look at low sag and how they can now look at different properties of it very quickly and tweak those properties to get the even more improved low sag properties. They've identified what makes it good for that now. Because you got to remember, you can make it where it's really, thick material with a high molecular weight, but you can't process it. So you got to have the best of both worlds. You got to be able to process it into something and make it stay in that shape while it's still molten. So now they're able to better define that and tailor it. So I think you're going to start seeing more and more of these things where we're going to be getting larger pipe and thicker wall pipe. So these things are just going to continue to grow, like Mike says. 65 inch, with a 4-inch wall will be everyday pipe at some point.
So resins will get better, right?
Resins are better,
Capabilities.
yeah. Definitely.
Extrusion equipment is getting better all the time, faster,
They
quicker,
already have it.
larger
Yeah. They
diameter.
got equipment to make up through 120 inch now, 2 meter plus, 3 meter, I think, actually.
This ESG thing, whether you're a believer or not, it's not going away, right? Call bullshit on it if you want, but it's happening. And people are going to ask you for data. How are you going to help me with my ESG? All of the big corporations are doing that now. Some of the private equity guys are probably having to do it as well. But water savings for sure. The climate initiatives are going to continue to be impactful. That's not going away. The piping market is going to grow. I think we've showed that already. It's not going to shrink or stay the same. It will continue to grow, which means our pie is going to get bigger, right? And we're going to gain market share. That's our goal. I think there's a few resources. David Fink's in the room. PPI is a great resource. If you haven't tapped into it, you need to. They've got lots of great technical data. The Alliance for PE Pipe, Peter Dyke, you guys are a great resource as well. Use those resources. That's what they're there for. There's some books. I actually was at the Pipelines Conference with Stephen about a month ago or whatever.
Just a few weeks.
I ended up buying a couple of books, and I thought, I'm going to get educated a little bit. And one of them I wanted to share, I won't read this to you, but they talk about cradle to grave. And as an engineer, what you're supposed to be engineering, what you're supposed to be looking at. It's not just pipe versus pipe, price per price. No, let's look at ESG. How much is the transportation? How long is the pipe going to last, right? Our pipe, 100-year life, right? They talk about that when they're engineering these projects. Get educated and think like them as well. But these are great resources, but go out and do some lunch and learns, go win some projects, and then promote it. Get it out there. As an industry, we need to promote more of it. We're fragmented. We're not always together or unified. We are an army. We need to support each other. Even if we don't win the job, let's continue to support each other, and let's go kick the shit out of the other guys. That's what we need to do, right? And Dave Hughes is buying cocktails, I hear.